गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरा गुरुसाक्षात् परब्रह्म तस्मै श्री गुरवे नमः.
Good morning, students. Today we are discussing computer codes. What are computer codes? A computer code is a way of representing text and computer instruction by the user using a binary number system. You know what are binary number? The binary numbers are 0 and 1. Because computer can understand only the value 0 and 1, actually these two 0 and 1 are not values for computer. In fact, they represent off state of a switch and on state of a switch. It can differentiate between these two. From my previous explanation, now we are having an idea how every data in computer gets converted into a binary number and how computer processes this binary number. So, a computer code is a binary code. It is a way of representing text or computer instructions by the use of binary digits 0 and 1. There are various kinds of computer codes, but in this topic we are discussing few binary codes and let us understand what are they and what are the users of these binary codes. Binary codes can be classified into many types, but the main classification is numeric code and alphanumeric code. So, computer code can be broadly classified into numerical code that is used to represent numerical value and alphanumeric code that can be used to represent alphabets as well as numeric. The difference between numeric code and the alphanumeric code is that the numeric code is used to represent the value, decimal values, whereas alphanumeric codes can be used to represent alphabets as well as decimal values. Next, the list of commonly used computer codes are given. Number 1, BCD code. Expansion of BCD is binary coded decimal. In short, it is called as BCD code. It is a numerical computer code. XS3 code is another type of computer code that is also used to represent numerical values. Extended binary coded decimal interchange code, in short it is called EBCDIC. Very commonly used computer code is ASCII. Expansion of ASCII is American Standard Code for Information Interchange. Let us know about the BCD code in the next slide. On your screen, binary coded decimal. In short, it is called as BCD code. It is a weighted code. It uses a weighted position and it is a 4-bit length code, binary code. So every decimal digit is represented using 4 binary digits in BCD code. As I already mentioned, the BCD code is used to represent the numerical value, and there are 10 different numerical values that can be represented using BCD, and there are 4 bits used to represent the BCD code. The 4-bit length binary number can produce 16 combinations, and it can be used to represent 16 different values. But in numerical, only 10 values are there. Therefore, though there is a provision for 16 combinations of BCD code, out of 16, only 10 BCD codes are used to represent decimal values in BCD code. Here the example given 537, which is a decimal number. How this number is represented using BCD code. A 537 is a value. It consists of 3 decimal digits, namely 5, 3 and 7. Now each of the digit of the 537 is separately considered and its binary number is obtained, and that binary number will be having 4 length and represented separately along with the respective digits within the number. That is, in this example it is very clearly given, 5 binary equivalent is 101. See, when we convert decimal number 5 into a binary number, its length will be only 3 digits. But compulsorily there should be 4 digits, because these converted binary numbers will be connected with the other digits binary number in a sequence. Therefore, every BCD digit in BCD representation should have a length of 4 binary digits. Suppose there is a short of any number of binary digits out of 4 binary digits, a bit 0 is added to the original binary number. So the 5, when we convert it into binary digits, will give 101. To make it 4 digit, so 0 is added. The next number is 3. When we convert 3 into binary digit, it gives 11 as the answer. So its length becomes only 2. But in BCD representation, every digit requires 4 binary digits. So another 2 zeros are added to the original value of, that is 11. So that makes 0011. This is very important to understand the BCD code, how it is represented. Similarly, the 7 binary equivalent is 111. There is a short of 1 binary digit for 4 binary digits. Therefore, a 0 bit is added to the 111. So, the 537 in BCD code is represented as 0101, 0011, 011 and 1. Since BCD is a 4-bit binary coded system, it can produce only 16 possible combinations. A new kind of BCD code is introduced. It is called as 6-bit BCD code. In the next slide you can see 6-bit BCD code. What is the length of this 6-bit BCD code? In the name itself you can know its length is 6 digit. This 6-digit BCD code can produce 64 combinations, and each combination can be used to represent some symbols. What are those symbols? Those symbols can be a decimal value 0 to 9, that comes to 10 symbols. Then alphabets A to Z, that comes to 26 letters, and a few punctuation and symbols are also represented in 6-bit BCD code. So totally 64 symbols can be represented using 6-bit BCD code. So 6-bit BCD code represent numbers, alphabets from A to Z, and 28 different symbols and punctuation marks, special characters and punctuation marks. Then, what is the structure of 6-bit BCD code? See here, the 4-bit is retained from the BCD code. The additional 2-bit is added to this 6-bit BCD code. That additional 2-bit is called zone bit. In the next slide, you can see the chart of 6-bit BCD code, the value that is representing in this. As you can see here, in the first column, the digits are there. The second column, 2-bit zone bits are there. In the third column, the BCD code representation is there. So the digits 1 to 0 is represented using the zone bit 00 and the binary code that is starting from 1, 10, 11, 100, 101 and so on. That is the binary counting. You can see that. Whereas the alphabets starting from A to Z is used, okay, to represent in BCD, that is 6-bit BCD code, the zone bit 11, 10 and 01 are used. Okay, so you can see there are 10 binary code and the zone bit same for all those binary codes, and the next 10 binary code, zone bit is different for all those 10 letters, and it goes on. This is how the 6-bit BCD code is used to represent numbers, alphabets and special characters and punctuation marks. Then what is the application of BCD code? Where do we use the BCD code? Basically, the BCD code is used to represent in digital circuits. Your wristwatch, if it is an electronic watch, the numbers that are produced in the electronic watch is generated using BCD code. Its major application is generating or developing electronic circuit to display digits. BCD code used. Next. Another type of computer code is XS3 BCD code. What is this XS3 BCD code? Basically it is a BCD code, but XS3 BCD code is not a weighted code. It is a non-weighted self-complementary binary code. There are some difficulty or disadvantage in performing two binary codes. See, for example, if I add the decimal number 6 and 7, that will produce the result 13. This is not possible in BCD code, so addition creates some problem with the additional bit. To overcome this additional problem, XS3 BCD code is introduced. So in the XS3 BCD code, the actual binary number is converted into decimal number. The sequence of binary number is converted into decimal number. Say for example 537. The 537 is represented using a binary number like 100111100 I just am giving the example. Okay. This length of binary number is converted into a decimal number. Say that decimal number is 537. This 537 value is converted into XS3 BCD code. When the process takes place, first each digit of the 537 will be considered separately and decimal value 3 is added to each digit of the number. That is, in 537, 5 plus 3, 8, 3 plus 3, 6, 7 plus 3, 10. Like that, the value 3 is added to that decimal number. So we got some decimal number, that each decimal number is again used to convert into a binary number, and that converted binary number is called XS3 Binary Code. In the next slide, there is a value given. The value given here is 24. 24 is directly represented in decimal number format. So, that value 24, each digit of the 24 is taken separately, that is 2 and 4. For each digit, additionally value 3 is added. That makes 2 plus 3, 5 and 4 plus 3, 7. Now the obtained result from this is converted to a binary number. That binary number is say 0101 and 0111. So this is what we call as the XS3 binary code. So 24 is represented using XS3 binary code as 0101 0111. Normally, I told you, the XS3 binary code is used to overcome the shortfall of addition of two binary BCD numbers. The next number or the next code, computer code, is EBCDIC. Expansion of EBCDIC is very, very important from the examination point of view because it may come for 1 mark also. If you look at the earlier question papers, there are so many times expansion of EBCDIC is asked. So remember what is BCD, expansion of BCD, what is EBCDIC, expansion of EBCDIC, and what is ASCII, expansion of ASCII. Now, EBCDIC is expanded as Extended Binary Coded Decimal Interchange Code. This is a 8-bit code especially used in IBM mainframe computers. You there are different types of computers, classification of computers you have studied. Let me refresh your memory. The different types of computers are classified as analog computer, digital computer and hybrid computer. It is based on operating principle. What about based on speed, performance, storage capacity and storage capacity? So the classification based on this is supercomputer, mainframe computer, mini computer and microcomputers. Now we are discussing. So what are mini computers? Mini computers are multi-user computers that you know. It is a very big, high capacity, costly, expensive computer. Basically normally used in large number of transaction calculations, business calculations rather I can say. What is the difference between supercomputer and a mainframe computer? Supercomputer is used for scientific calculation and the mainframe computer is used for business transaction processing. Okay, so IBM has manufactured a machine, a mainframe machine. In that machine, this EBCDIC code system is used. It's an intermediate code. What is the meaning of intermediate code? Before it is translated into a binary code, a number is given to identify every symbol that can be used in that particular language. So EBCDIC is a 8-bit code. Using 8-bit, we can able to produce 256 different combinations, unique combination. Each combination can be used to represent a letter or a symbol or a control character, whatever is possible in computer keyboard that can be used to assign a code in EBCDIC. Now, the letter A in EBCDIC, for example, given on the screen, it is 1100, 000 and 1. So, totally 8 bits are used to represent every symbol that are used in the IBM mainframe computer. So, EBCDIC is a alphanumeric computer code. All kinds of alphabets, digits, special characters, control characters and the symbols are represented and can be represented using EBCDIC. After all, we have different, as many as 256 combinations of binary code. Many characters can be represented using almost all characters can be represented using EBCDIC. The next computer code is ASCII, American Standard Code for Information Interchange. It is very commonly used in microcomputers, desktop computers, home computers, laptop computers, PDAs. So, the disk operating system or Windows operating system uses this ASCII chart as an intermediate code to interchange the information from one type to another type. Now we use keyboard to type a letter. So letter A when I type, in ASCII a code number is given for that letter A and that code number is converted into binary code. So what is that code number given to that letter A or B or C or D or E in a desktop computer keyboard is given using ASCII. So ASCII can be used to represent alphabets, numbers, special characters, punctuation marks, control characters like enter key, alt C, control C, control V, control Z, control A, like this, tab key, backspace key. Each and every key has a ASCII code defined in the ASCII chart. So, there are two forms of ASCII. One is 7-bit ASCII and 8-bit ASCII. The 7-bit ASCII can generate 128 combinations or codes, whereas 8-bit ASCII gives 256 codes. So what is the difference between 7-bit ASCII and 8-bit ASCII? 7-bit ASCII, there are 128 codes. 8-bit ASCII, there are 256 codes. So, ASCII is a alphanumeric computer code. I am showing the ASCII chart in the next slide. Let us look at the slide. If you see this chart, it consists of 0 to 255 symbols. The first number is 0. Look at the last column, last value 255. Including the 0 up to 255 means 256 symbols. Okay. Now, let us see what are the ASCII code for the familiar characters from this chart. Look at the second column. First value is 32, that is not a serial number, it is a ASCII code. The value 32 is a ASCII code that represent space bar, a space character. Suppose I use the space bar, that will produce the space. Okay, so that code is 32. Next one is, look at the digits 0, 1, 2, 3, 4. What are their ASCII code? 48, 49, 50, 51 and so on. Then alphabet, capital alphabet, there is a code. For small letter alphabet, there is a separate code. 65 is the code number to represent capital letter A. And if you look at the small letters, 97 is the ASCII code to represent small letter A. So from this, you can understand how the ASCII code are used to represent different symbols using ASCII chart. So this chart is a 256 symbol chart, that means ASCII 8-bit chart. So, dear students, from this I can conclude this chapter. I hope the concepts and the topics are dealt very clearly in a very understanding manner to you. I hope all the sessions that are handled is clearly understood without having any doubts in your mind. So whatever we have discussed in the chapter 3, that is data representation, can be seen in the next slide. We started with the introduction, what is data? So then we started with the number system. What is the significance of number system? Why we have to study number system? Because data, the way in which we handle, will not be fed into the computer in the same format. It will change its format from user understandable format to machine understandable format. So, We discussed about the number system, different kinds of number system, that is non-positional number system and positional number system. Example for non-positional number system is Roman number system and Mayan number system. And we studied about the positional number system, structure of positional number system. So there are different types of positional number systems, namely decimal number system, binary number system, octal number system and hexadecimal number system. So what is the base of these number system, and how do we understand what is the base of every number system? 10 is the base of decimal number system because there are 10 unique symbols used, and 2 is the base of binary number system because there are only 2 digits used, and 8 is the base of octal number system because 0 to 7 digits are used to represent in octal number system, and 16 is the base of hexadecimal number system where the decimal 10 is used, and additionally the 6 symbols are represented, the values are represented using letters A, B, C, D and E and F. Okay. Then we discussed about different kinds of number conversion from decimal number to binary number, decimal number to octal number, decimal number to hexadecimal number and vice versa. We also discussed what are the shortcut methods that can be used to convert any binary number to octal number and also hexadecimal number. Then we also discussed about the representation of a signed number. What is a signed number? A signed number is nothing but how do we represent positive and negative number in binary number system is the discussion point of signed representation or representation of signed numbers. There are 3 methods discussed in this chapter. They are called sign and magnitude representation, one's complementation representation and two's complement representation. So then we discussed about the binary arithmetic, which is very interesting and mathematics oriented, how the addition and subtraction are performed in binary arithmetic. We also discussed the different rules of the binary addition, and we also understood why the addition rule is very, very important because using addition, every other operation can be performed, that is subtraction, multiplication and division. That also we discussed in earlier sessions. So the 2 methods that are used to represent the negative number and to perform addition operation are one's complement method and two's complement method, and we did a few exercise and by considering examples to perform differences or subtracting 2 numbers using one's complement method, subtracting 2 numbers using two's complement method. So here we discussed about considering a smaller number with larger number and larger number with smaller number, and how the final result is obtained, what is the difference also dealt in detail. Finally, this chapter is concluded with computer codes. What are computer codes? Why computer code is required? Okay, what is the classification of a computer code? So that is a numerical code and alphanumerical code. Example for numerical code is BCD code, 6-bit BCD code, XS3 BCD code. The examples for alphanumerical code is EBCDIC code and ASCII code. Of course, there are many other codes out there, but that is not the point of discussion in your chapter. So, dear students, from this, I am concluding this session. You have to solve the questions that are given at the leisure hour. We told failure to, and I also insisted you to consider other several examples and learn how to calculate or how to subtract numbers using 1's complement and 2's complement method. Thank you very much.